Reporting for Fun Robotics Network, I'm Yashis, and with me today on Behind the Bot is Team 27971 Null Pointer Exception with an incredible robot with lightning-fast linear slides for both extension and horizontal reach. Learn more about their robot on Behind the Bot. So to start with your robot, let's talk about the overall design strategy that you created when the game challenge first released in September.
So when the game first released, I really struggled with, since we were registered late, we had to create our own team. We really struggled with getting time to design everything. So at first we only really had the vertical lift with a long arm, and that was not very good. So we added the horizontal extension as a way to be able to get maximum reach when we were designing. And we knew that we'd have to have a transfer, and we went with a claw to claw just because it takes one more step when you compare it to like a claw to bucket to claw.
That's amazing. And let's move further on into your drivetrain and what you use to control it, odometry, that sort of thing in software.
Okay, so for our autonomous, we have SparkFun Odos right there, and it's the laser tracking module SparkFun has. It's not the most accurate, but we found it to be more than enough for what we needed it for. And for our drivetrain, it's just Gobilda 312 RPM motors on a 17:24 ratio with belts, because we didn't have 435s.
Yeah, that's amazing. Your robot was really fast in competition, and it's always zipping around. That's nice to see. So let's talk about your intake claw. What sort of design prototypes did you go through, and how did you ultimately end up on this solution?
Okay, so our original intake claw just had a single finger, and we tried to go into the middle of the sample and kind of pinch the edge, but that was really hard to transfer, and it wasn't very consistent on how it grabbed. So we switched to just a standard herringbone claw design for both of our claws. And we started originally with this claw just being the same as this one, but we needed to optimize the geometry. So let me get a sample. If they get a sample from me, you can see that pivot. So we pivot our intake down, and if it grabs towards the edge now, it'll kind of push it over so it can't be too far to one side, which was to solve an issue that we had with our transfer, where it would not always grab properly when the sample was all the way to one side.
Yeah, and then talking more about your outtake, how did you decide on sort of 2 super speed servos on each end as opposed to 1 torque servo or something of that sort?
So we actually originally did have torque servos, but it was really slow and we had to wait for them to move when we're transferring. So we switched to speed servos, and we were able to get our transfer down to, you just saw it there, it's quite fast. We just grab and it transfers in about half a second, which is way faster than we had on torques.
Yeah, and then next, let's talk about your horizontal and your vertical slides. What sort of system did you use to develop those, and how did you make them so fast?
Okay, so for our horizontal slides, we just used I believe this is a 45 millimeter spool on a Gobilda 1150 RPM motor, and we just decided to rig one side of the sides because it's a pain to rig both sides, and it's already relatively stable with just the one. And then for the vertical lift, it is 3 435 RPM motors on 16:24 ratios. So I believe that's an output of around 650 to 700 RPM. And they're on 45 millimeter spools there. So we have a time to goal of less than a second on those, which allows us to be at the bucket before we even arrive there.
Why did you decide to use 3 Gobilda motors instead of 2 that a typical team might use in their season for slides?
So we originally wanted to hang on 3, but we discovered that we just didn't have enough torque with how heavy our bot was, because it's almost entirely aluminum. So we just made the ratio more aggressive so we'd get even more speed, and the 3 higher torque motors helps kind of balance our power draw out a little bit than having 2 1150s.
And then lastly, let's move on towards the software that you guys use for the robot. I know that you have a lot of software knowledge, and your team has a lot of software intricacies and developments that make your robot much faster than the typical FTC robot. So let's dive deeper into those.
So yeah, I was originally a programmer before I started designing robots, so I jumped into this year really wanting to do a lot of software stuff. So at the start of the season, a software library called Mercurial released, it's kind of like an FTC lib, it's a command base, and allowed us to split all of our robot into its base hardware mechanisms, like the horizontal slides, the vertical slides, the claws, the pivots, and then from there we were able to chain the movements very easily with those commands. And then for auto, we use a modified version of Roadrunner, so we use the same software parts of the back end of Roadrunner, but we use our own follower and auto builder, which gives us really fine control of how we use those commands within our auto.
Yeah, that was incredible. Is there anything else that you'd like to tell the audience about your robot or your team that you think is really cool and unique for this season?
The biggest thing is that we were on a school team that was not very good in the past, so we were last in our league tournament 3 times in a row, and we were just really happy to get to our state championship, and we made it to playoffs, and we're really proud of our robot, and we're glad that we got to have a senior year like this.
Thank you very much for joining me on Behind the Bot, and I hope to see you guys on the next video.